Hey everyone, it's Mrs. Lawrence, and I'm here to talk to you about subtracting polynomials. So we've looked at adding, so now we're going to look at subtracting. And if you could add polynomials, you'll be able to subtract polynomials. Because similar to adding, if you could add regular numbers, you could add polynomials. You can subtract regular numbers, you can subtract polynomials. So let's go ahead and get started. So we're going to start by looking at this problem here. 3x squared plus 2x plus 7. And from that, we're going to take x squared plus x plus 4. So similar to adding, when you had to only do it with like terms, same thing with subtracting. Only like terms could be subtracted from one another. I cannot come over here and say, oh, I'm going to take this x away from 7. No, you're not, because that 7 doesn't have any x's. Same thing, I can't take x squared from 2x because this x does not have an x squared. Just this one does. So the first thing though, before I do anything else, is I want to go back to my integer rules from middle school. Middle school is going to continuously haunt you here in algebra. And we're going to remember the old thing when you were probably like, oh, I don't know, I think it's 6th grade math. So again, like I taught 7th grade, I've also taught 6th grade. So we're going to, step one is we're going to change our subtraction to addition by change. Yep, I'm running out of room here. Change. So what that means is this. You probably remember, or I hope you do, when you were in school, if you had a problem like, I don't know, 3 minus 12, right? So they're like, oh, 3 minus 12. Well, what we're going to do is we're going to keep the 3. There's the keep. We're going to change our subtraction to addition. There's one of the C's for and then the 12 is going to be changing to its opposite, which would be negative 12. The keep, change, change. We kept the 3, changed it to plus, changed it to negative 12. So then we have 3 plus negative 12. Well, 3 plus negative 12, that's going to be negative 9, okay? So that's what that whole idea is. So when we look at our polynomials, we're going to keep the first polynomial the same. We're going to keep this. This is being taken out of this. So we're going to keep this the same. So step 1 here. So we're going to keep 3x squared plus 2x plus 7. What's going to happen is we're going to change the other polynomial. So we're going to change this polynomial. I'm going to change my negative or my minus to a plus. And everything inside of those parentheses is going to become its opposite, meaning if it was positive, it's now negative, or if it was negative, it's now positive. So now I'm going to have negative x squared. This positive x is going to become a negative x, and this positive 4 is going to become a negative 4. And I also took out the parentheses because we really don't need them anymore. It's not necessary. I'm going to autofocus this. I'm looking a little blurry. It still looks a little blurry. Let's try one more time. Yeah, it still looks a little blurry over on this side. It could just be me. So that's step 1. So this was step 1. And step 2, we are going to combine, because now we have an addition problem. We've already done adding, so we can do this. So we're going to combine the like terms to add. So I am going to, in step 2, I'll bring this down here. So we have 3x squared plus 2x plus 7 plus negative x squared plus negative x and then plus negative 4. So I'm going to take this problem from step 1 and I am going to identify my like terms. So I got some colors here. So I see I have 3x squared. Do I have any other terms that have x squared? You don't? You don't? Ah, x squared. Hi, you can be purple too. No and no. So I only have those 2 terms. So I'm going to look at the next term. I see 2x. So I'm going to make this one red. Do I have any other just an x? No, you don't have an x. You're already accounted for. Oh, here you are right here. And you don't. So that leaves us with, we have a 7. Do we have any other just single numbers? Oh, yeah, we do. Right there. So now that I've identified my like terms, what I like to do is I can group them together to make my math a little bit easier. Once you get fancy with this, you don't need to do this as much. You can do this in your head, but for right now, what I'm going to do is I'm going to start with the purple terms, and I'm going to rewrite them by reorganizing them. So I'm going to bring 3x squared, and then I have plus negative x squared. You can also throw a 1 in front of that because there really is a 1 there. He's shy, but we're going to make him not shy anymore. And then we have plus 2x, and then my other red term I have is negative. Again, I'm going to put the 1 in front of it, 1x. And then the yellow terms I identified were plus 7 and plus negative 4. So the last part is just to bring these together, right? So I have this purple here, and I am going to bring this together. So this purple, so I have 3, I'm just looking at the coefficients. Don't even worry about the variables, just look at the coefficients. So we have 3 plus negative 1, 3 plus negative 1. It's really the same thing as 3 minus 1. If you're not sure, also use your calculator. Throw in your calculator 3 plus negative 1. You don't have a calculator? On my Schoology course, there's a calculator resource in the Bitmoji classroom. So 3 plus negative 1 is 2x squared. And then I have 2x plus negative 1x. That's just like saying 2 minus 1. So 2 minus 1 is just 1x, or x. And then we have 7 plus negative 4. Again, that's the same thing as saying 7 minus 4. And we can just say that that is 3. And I know it's kind of spaced out. That's okay. And voila. Cannot make this any smaller. You put a 1 there, it's not the end of the world. Can't make this any smaller. It is what it is. Don't try and make this like 6x squared or 6 or just whatever. This is it, okay? So let's look at another example. Let's look at another example real fast. So another example is 9y squared minus 3y plus 1. And from that, we're going to take away 2y squared plus y minus 9. Again, I'm going to follow those steps from above. So I'm going to keep change. So I'm going to keep 9y squared minus 3y plus 1. I'm just going to get rid of the parentheses. I'm going to change my subtraction to a plus, and everything inside the second set of parentheses is going to get swapped to its opposite. So that means it's going to become negative 2y squared. This positive y is going to be now a negative y. And this negative 9, he's now upgraded to a positive 9. So again, I'm going to identify my like terms. I could get my fancy colors out, but I'm just going to circle. Here's those like terms. So we have 9y squared plus negative 2y squared. And then let's see, I'll underline negative 3y. Right here is another y. And so now I have plus negative 3y, and I have plus negative y, and then let's box our constants, last but not least, so they don't feel left out. Plus 1 plus 9. And so now I'm going to bring together those like terms. These are like, those are alike, and those are alike. So we have 9 plus negative 2, again, is just 9 minus 2, which is 7y squared. And then we have negative 3 plus y, negative 3y plus negative y. So remember, there's like an invisible 1 that's right here. I'm going to squeeze them in there. So negative 3 plus negative 1, signs are the same. Add the numbers and keep the sign. So it's a negative 4y. And then 1 plus 9 is just 10. So our answer is that. It's kind of spread out. I'll rewrite it down here, so it's not as spread out. Okay? We're going to look at one more thing before I let you go and practice on your own. We're going to look at this question, because you are going to have a question like this, and you need to be aware of how to solve this. Okay? So we have the figure below has a total perimeter of 26x squared plus 20x plus 16. The length of side A is 3x squared plus 4x plus 2. What is the length of side B? So one thing I need to know is I need to know, what does this word perimeter mean? This is a term, you may not have seen it for a while, but yes, perimeter. Good job. Yes, you are correct. I'm assuming you all know. It is when it's the distance around a shape. So it's when we have to add up all the sides. So what they're telling us is when we added all the sides of this rectangle, it came to this 26x polynomial. They're telling us that the length of side A, notice there's two sides that have A because it's a rectangle. this side and this side are the same length, is 3x squared plus 4x plus 2. We need to figure out now what is the side of B. So we're going to have to do some deductive reasoning, okay? So I know perimeter is when I have to add up all of the sides. So I'm going to add up all of the sides. So I would have A plus B plus B. And we are told that the perimeter is 2x squared plus 20x plus 16, okay? So I know this. I also know that side A is 3x squared. So I'm going to replace the a's with this 3x squared plus 4x plus 2. And then I have two sides that are labeled A. So wherever there's an A in this problem, it's this value. And then B, and it's going to be 26x squared plus 20x plus 16. So it's just a solving an equation. So I'm going to combine the like terms that I have on this side. So I have 3x squared and 3x squared, so I'm doubling it essentially. So 6x squared, 4x and 4x would be 8x, and then 2 and 2 would be 4. And then I have this plus B, which is like 2b, because there's two of them. And then it still equals this. Okay? I'm trying to make sure I don't get cut off of this video. All right, so if I remember how to solve an equation, I need to take this from this side. Here's where the subtraction is going to come into play. So I'm going to subtract all of this from each side to get my variable by itself, our variable being B. We're trying to solve for B. So those cancel out, and we're left with 2b on that side. Now I'm going to subtract. What is 26 minus 6? Yes, it is 20. So we have 20x squared. And then we have 20 minus 8, which is 12. Yes, there's a plus sign here, but remember, it's out here. There's my minus. And then we have 16 minus 4, which is 12. Now, that tells us what two of the b's are. We want to know what one is. So I need to split this in half. So I need to split in half. And think about what operation splits things in half. You guessed it, division. So I'm going to divide both sides by 2. B equals, what is 20? What is half of 20x squared? It would be 10x squared. And what is half of 12x? It would be 6x. And then what is half of 12? It would be just 6. So B equals that. Okay? We will do more practice of this in our Google Meet, so if you're still feeling lost and confused, that's okay. I will be here to help you, okay? You got to make sure you show up, though, and feel free to rewatch this, and I will see you all soon. Bye!